This is one video of many. The links to the other videos are in the description. If you go to ipengineering.us and then go to this apps tab, this is where the project is outlined and documented. In here I have a bunch of fundamentals, a bunch of the utilities that we'll use like file IO, joystick, a bunch of the libraries that I wrote, and then down here will be all the progression of the videos. This is really the best place to kind of follow it along and fill in the gaps. And then of course on the YouTube page there will be all the videos. I don't really recommend trying to follow through on YouTube. I would go to the website to get more of a clear direction. We left off in the last video on how to configure our solution to get our C++ DLL and our C# application all set up. This video, we're going to add functionality to that by using OpenCV to do some image processing. And we're going to do half of the marshaling between our C# application and the DLL to get our images to show. This application is dynamic, so I want to be able to resize this, change the window aspect ratio, but preserve the aspect ratio of the image we're showing. So we have two images. We've got a background image and a foreground image, and all of that processing is going on in the DLL, and then we're just pushing the essentially pixel data to C# to render it in the window. First thing we want to do is add some elements to our Forms app. So this is a group box, this is a panel, and this is a rich text box, and you can get all those from Toolbox. Just float over it, grab it, and drag it in. Then what we want to do is set the anchor on the group box. It's going to be in our properties. Come down here and look at anchor, and we want the top, bottom, and left. And then the rich text box, same thing, but bottom, left, and right. And then on our panel, we want to set the anchor on all of them. Then we could test our functionality by hitting run and seeing if our resize works the way that we want it to. So again, it's not black, and I put a border on here so that we could see it a little bit easier, but as I resize this, all of the size of everything is maintained as I think that I want it. At this point, we can start to spend a little bit of time on style, so this is just how I do it. Feel free to play around, get familiar with what each of these properties does. Go in and change things like back color. So for example, I could change it to maroon and you can see what it does. I like to use the web colors because they're essentially readable. Things that I've changed are background color of the form, and then these two things are going to be transparent, and then the back color of my rich text box to black, and then I changed the foreground to lime. That's how I got the font like this. I changed the text of form 1. That gives me the text up here, and then the application icon is right here, and I usually make my icons in GIMP, and then you just hit this to browse and go and find your icon. So this is my little icon that I made. Now if you run this, you saw that these are by default gray, and what we want to do is change it to green. Looking at the code for that, what we want to do is add an event for our group box. So again, in the properties box, change it from properties over to events by clicking on the lightning bolt. And then I want to add a event for the paint thing. So just double click it and it will create a callback for you. And then what we want to do is create a user defined function that we are going to write right here. But what we want to do is paste this code. So here we're just creating a group box object, calling it box and populating it with some of these things here. And then the code inside the function, I'm not going to go through line by line, but essentially it uses the graphics objects to recreate the box after we clear it. What the paint event means is every time this window changes or goes behind something or changes size, that paint function is going to get called and it's going to get redrawn. If you're unsure what calls this paint function or how all of this code is actually working, it's a good time to familiarize yourself with event-based programming. In a C++ program or a Python script or something like that, it goes line by line and executes functions as we see them. We look at the code, it's going to do this one before this, or here it's going to kind of just cascade going down. Like, that's really easy to understand, but what actually calls this paint function? That's all Windows. So these are all Windows messages, and when we go into the auto-generated form designer, we see all of these event handlers. This is how Windows works. Every time the mouse moves, every time a key's hit on the keyboard, every time there's an action that a program wants Windows to do, it's all through messages. So these message handlers are the way that we're communicating, or our application's communicating with Windows itself. So essentially, Windows is throwing all kinds of messages out there at every single application running, like, hey, somebody move the mouse, or somebody hit a key on a keyboard. If we don't program our application to care about those messages, it just discards them. When another window goes over our application, Windows is the one that triggers this paint function to execute. And that's a big difference between a Windows Forms application and then a traditional scripting thing like we're used to with C++. I'm going to close this topic on Windows messages with just this. I get a lot of comments about, why am I not using Python, or how about JavaScript, or how about, this other thing over here, why not use a more modern .NET thing? Like, every programming language has its strength, but the simplicity and commonality of Windows Forms, and the fact that I can deploy this on almost any computer with minor foresight on my end, and especially with Visual Studio taking care of that, and it's old enough where there's so much documentation out there. All of the ones that aren't in Visual Studio are not specifically designed for Windows, and you wouldn't believe the amount of stuff that's going on behind the scenes that Visual Studio is just taking care of for you. It's so simple, so easy. Like, do yourself a favor and try and program a GUI in straight Win32. It would probably take you a year to do it if you're not familiar with it. So why am I using Windows Forms? Because it's so easy. I don't care about my front end. All the power that we're going to be doing in our application is all going to be in the back end. So I don't want to focus at all on my front end. I want to put all my effort into processing efficiency, graphics, all that stuff, and all of that's going to be in the back end in C++. I want to shift the focus to implementing libraries in our DLL. So for example, if we want to read an image and save it to an OpenCV matrix, how would we go about doing that? What we have to do first is force our C# application to even load the DLL. And the way that it's going to do that is if we go into form1.cs, I just put an init function inside our form1 constructor. And the way that Visual Studio by default sets it up is it will only load the DLL on the first call. So if you don't include this, it'll never load the DLL. In the last video, I talked about how to do all this with all the keywords, prototypes, class definitions, the pinvoke function, all of that stuff. So I'll just blow through it really quick. We have an init function that takes 2 parameters, okay, and they're integers. And in this case, I want it to return nothing. I am using the header file. We're going to come back to this. And then here is our definition for that init function with all the export declaration. And all we're trying to do with this line here is that when the DLL loads, what I want to do is use OpenCV to read this image and stick it in memory as an OpenCV matrix. Even though we have OpenCV installed on this computer, we're still getting Intellisense errors. And that's because Visual Studio has no idea where OpenCV is, how it's installed, and normally, or I should say, unlike programs like Python and things, when you install modules in Python, it automatically sort of configures itself such that Python can find it. It's not that way in Visual Studio. There's a lot more flexibility and a lot more like granular control. So on one side, it's a lot more powerful, but on the downside is the learning curve is steep. So what we have to do is get our project configured to find all of these things, header files, library files, all that. So let's go through generically because this process is the same for all libraries. Let's look at the CV load image color keyword here. Somewhere in the OpenCV documentation, there's a place that says define this string of text to equal some number, like 3 or a 128, or maybe even some other object, or points to a different data type. All of that sort of stuff, all of these namespaces, they're all going to be defined in some kind of header file. For us, the example that we got this from told us to include this header file. To configure Visual Studio to know where to get that header file, what we do is come over here to our Solution Explorer, right-click on the DLL project, and go to Properties, C++. In the General tab, there's this Include Directories. Make sure that this is on all configurations and find the directory for your OpenCV installs. For us, it's going to be in this OpenCV build include. Select folder, hit OK, and then hit OK here. And then this should go away. Now it knows where to get the OpenCV header files. And if we come in here, our IntelliSense says, oh, now I understand what this means, but this still won't compile. Oh, okay, so it's a link error. And the linker is what goes and gets all of the actual code out of the library. So what we need to do is tell it where to get the library file. So same process, come back over to our project, right click, properties, go into linker this time, input additional dependencies, and this time we don't want all configurations, we actually want to do these independently, and that's something special for OpenCV. Have a different library for the debug mode and then an optimized one for the release mode. Configure this one for that. We're going to configure this one for the debug and then put in the same thing but without the D for the release mode. Okay. Okay, so we told it which libraries we're using, and now it says it can't open it. So we're going to go one step further. We go into properties, we're going to go to linker, general, and then we need to tell it where the library directories are. We could go to all configurations again because they're in the same spot, and then pick our directory. Okay, so now Visual Studio knows where the library files are and which ones we plan to use right here, and we hit OK. There's still one more step to do. So remember when we configured our application last time, we want the exe and the DLL file to be in the same folder. Well, because we don't want to copy the Visual Studio DLL, we could just paste it in here. It's only 40 megabytes, but if you're doing multiple projects, you want to just configure Windows to be able to go find the DLL outside of here. So that's something called the search path, and then that's where you have to do the environment variables. So this is going to be in your system properties, environment variables. In system variables, find the path. Okay, and then add OpenCV into here. So I already did it, so mine should run no problem. And I get my thing, and I don't have any exceptions, so everything's good on my end. Now that we have Visual Studio configured to use OpenCV, we need to start adding some functionality. If you're wondering why this thing's called Cypress, if we go to the Wikipedia page for Library of Alexandria, the head librarian resigned from his position and exiled himself to Cyprus. These videos are so excruciating to make. It's so boring. You think it's boring to watch. Try making these things. So that's why I call this application Cypress, and I'm going to call the library that we're going to generate Alexandria after the Library of Alexandria. If you're with me, send me some love. This is even more painful for me than to try and sit through these things, I can only imagine. At least you get to pause and walk away. To make it easy for us in the future, we're going to create a class that holds all of the pertinent information and holds all of the data for the actual image that we want to push to C#. Some of the things that we're interested in are the height and width of the screens, and then obviously we need the memory for the background image, for the actual data that we want to show, and then a sort of compiled image, which I call rendered, then this is what's actually going to get pushed to the screen. So we need a constructor, deconstructor. We definitely need to set size. And then there's some other functions in here like set background and set data. As we start building the CMM, obviously we're going to need a way to like update the data. We need a render function, and that's going to kind of deal with some of the sizing and ultimately the image processing to get this rendered image prepared. We're using OpenCV to handle all the memory internally. If it decides to move one of these matrices, we always need to ask where that image data is. So this is the header file for that, and then we create all of the underlying code. So don't try and type this out from the screen. Again, all of this stuff is going to be on the website. We have our constructor, and we're cheating here, and we just read the images when we construct the display object, right? So eventually this will be in that sort of set data function, but for right now, right when we construct the display object, it goes and grabs this image, or tries to. So see here, this is my little like unfinished convention here saying I need exception handling, because if it can't find this, the program will crash. It's just like the DLL, it needs to be in the same directory as the exe. And then set size, this one's important. So when we change the size of the front screen, we're going to push it through here, and then it's going to create a new matrix, a new image in that size. Okay, so every time we resize the window, it actually reallocates memory. But again, because this is all OpenCV, it handles it pretty effectively. And then once it's done doing that, it calls this render function. And here's kind of the heavy lifting in the processing. And then the get image pointer function literally just passes the pointer that's returned from the OpenCV object. How do we use that? Instead of having an init function that does nothing, we're going to add a little bit of functionality. So I'm going to initialize with the screen width and height, and then I'm going to pass that to the display using the set size thing, and then I'm going to immediately try and render that. I need an update screen size function, and essentially it's going to do the same thing. This is going to get called every time the C# application calls that paint function, essentially. And then we need some way to pass the pointer through to our C# application. So this is tricky. So what is an unsigned character if this is an image? So if you're unfamiliar with character arrays and multi-dimensional arrays, on the website, here's some fundamental stuff. And in here, it talks about how to deal with arrays and how they're stored in memory. So an image, being a 2D array, is really just an array of pointers, and then that array of pointers itself is handled by the memory location of the first element in the array. Okay, so I can sort of handle this entire 2D array by just the address of the very first element. That's why it's an unsigned character, pointer to an unsigned character, because the entire data type is, or my entire 2D array is just unsigned characters, 8-bit, 3 channel per pixel. What this is doing is it's passing through the address of the first element in the first pixel. And following this unsigned character through the prototype into our C# interface, that gets marshaled across as an integer sized pointer. In the .NET framework, they do not want you to use pointers. It's considered unsafe, and it's kind of one of the benefits of using C# is that you don't have to deal with that. But when we're dealing with low-level things like images, we kind of have to force it to do it. Back to the Form 1 designer, we added a picture box inside of our panel. The way that we're going to marshal across our images can only be done in integer multiple size. We don't have control over what size the window ends up being when we resize it. What we do is we use the panel to track the size of the window. And then what we'll do is we'll calculate those integer multiple discrete steps, and we'll force our picture box to be that exact multiple but still fit inside the panel. And to implement that, once this initialize component function is called, the form loads, and then whatever size that is, we want to immediately go through and fit our picture box to our panel. Just like we had that callback for the resize or paint event in our control or our group box, we want to create an event for our panel that says resize, and then we could just throw in the code. All it does is when the panel needs to be resized, as long as it's not 0, this little if statement's here just so when we minimize it, it doesn't throw an exception because you can't have an image that's 0. So as long as it's not 0, fit the picture box, which means make it an integer multiple of 4 that still fits into the panel. Update the screen size in the DLL, and then inside the DLL it will re-render the image. Okay, and then we call this update image function. This update image function is another one that we write. And this is where we are creating a new bitmap image from the image pointer that it returns. Okay, and so even though this sounds like it's copying data, I don't think it is. So this, what it's doing is it's creating a bitmap header on the image data that's in OpenCV. Then what we do is we push that bitmap image to the image object in the picture box and call refresh. And that's it. And when we run it, we can see that it works.